Hello, welcome to Wireless Frame Analysis with Scapy. My name is Jamie Jackson. I'm a systems engineer based out of Montana, and I deal mainly with wireless mobility services. A couple disclaimers here. Previous Python programming, wireless knowledge, you don't need it, but it would be helpful. I do try my best to explain the concepts behind things, but if you don't have some of that knowledge, you may just not understand some of the nuance there. And then this is proof of concept code, nothing for production, so please don't send me hate mail if you notice that I'm not doing something proper with Python. So with that being said, let's just dive in here. We're going to deal with two different things here: wireless frames and the Python library Scapy. And the wireless frames, we're just going to kind of do a quick review, primer on those, because that's going to be the thing that is we're pulling in packets, frames using Scapy. We're going to be able to dive right into those frame contents and grab information out. So there are three types of wireless frames. We've got management frames, control frames, data frames. And so you can see in the image here, they each have a different type. And so all management frames have this type 0, all control frames have type 1, and all data frames have type 2. Management frames, they're what kind of control client and AP access. So we've got our beacons and our probes, association requests. Those are all management frames. Control frames, they control access to the medium, to the air, plus some acknowledgements. We're not going to be looking into those today, but control frames are important. And then finally, data frames. And data frames are exactly how they sound. They are the frames that carry our data. So each of those frames has a subtype, has multiple subtypes. We're going to be looking specifically today at beacons and probe request. So beacons on our handy chart here, they are subtype 8, which this is listed in binary, but 1000 is 8. We're also going to be looking at probe responses, which are subtype 5, 4, and 1. So those are going to be the two that we are going to be drilling into once we get into the program. And so we're going to pop out of the slideshow here real quick. And what we're going to look at is what is a problem that we can solve with Scapy and involving wireless frames as well. So one thing that we can use this tool for is we can find out what hidden networks. So right now, this is a scan of hidden networks where I'm at, and we don't know the SSID of these. We know the BSSID, kind of that, what I'm going to call a virtual kind of identifier of an SSID on an access point, but we can't see the SSID. And this is because in beacon frames, when you have chosen to hide the SSID, the beacon frame will only show the BSSID. And for the SSID, it will show nothing. It'll show an empty field. And what we'll do is we'll look at that here in Wireshark. So we'll take a look at a beacon here. And so we've got a couple here. We've got one here where this SSID field is blank, and one where we have a name in it. So let's take a look at one. Well, first, we'll take a look at the one with the name in it. And in here, this is all of our information, a little bit, all the stuff included in this beacon frame. But what we're really looking at is we're looking for this parameter right here, SSID Gunslinger, which is my local SSID. If we look at this packet here where we're not seeing this, everything looks the same except uh, we don't have an SSID here. There's nothing. It's empty, and that is a beacon for a hidden SSID. So uh, if we kind of recall why people use hidden SSIDs, a lot of it is they think it's a security feature. And as we're going to prove today, it's very trivial to get the SSID for a BSSID, even if it's hidden. It's very trivial. So it's not a security feature. In fact, it's probably the definition of security through obscurity. There are some valid uses for hiding a network. A lot of times it's an administrative type requirement in that, say we're a corporation, we've got an employee SSID and we've got a guest SSID. And we don't want guests to pull up a list of networks, see our employee one, and our employee one may or may not even have the word employee in it, maybe just says corporation name. We don't want guests to click on that and try and connect, and now they can't connect because they don't have the proper credentials, so then they call the help desk or they complain to the receptionist up front, and they just cause a little bit of a headache. So if we do hide the network in that case, and we only make the guest network visible, then we reduce maybe some administration type headaches. So that is a valid use case, but a lot of times I have found anyways that when I come into a network and they're using hidden SSIDs, they view it as a security feature, which it is not. So how can we find that? So we're going to kind of do a high level overview here of the steps to how we can find what the SSID is for a given BSSID when it's hidden. And then we're going to move into the code portion of it, and we're going to actually review the code that will help us through that process. So from the high level view, we've got our beacons. We've kind of already discussed that. They're sending out on a hidden SSID, they're giving us the BSSID, they're giving us this value, but we're not getting anything in the SSID. So the way that we can figure this out is in those management frames when we looked at, the other frame I said we were going to look at is the probe response frame. So when a client that is trying to connect to a hidden SSID wants to connect, you need to manually configure the parameters in the network profile. So typically, like in a corporate environment, you would have control over those devices that you want connected to your corporate network. And so you would either push out network profiles via something like a group policy for Windows machines or MDM for BYOD devices. And that would have all those parameters, including the network name that we have hidden, just if you pull up a network scanner. So when the network name is hidden, the way those clients are going to connect, because if a client comes into an area where we have an AP that should have that SSID, there's no way of knowing that SSID is there because our beacon frames are showing a null value, nothing there. So a device has a pre-configured network profile. It's going to send out a probe request. And that probe request is going to say, hey, I'm looking for this SSID. Please respond if you have this SSID. And so we'll pull up Wireshark here, and we'll look at our probes. And we'll look at a probe request. So we'll look at a probe request for, let's see, for this one, this MSU Bobcats. This is a network that I have saved on a device for a client, and it's a hidden network. And so this probe request is saying, this is the SSID I'm looking for. And then it's going out, as we can see here, it's going out to the broadcast. It's just sending it out to everything that can hear it, and it's hoping to get a response back. we're not going to see a response in this case for this Bobcats because I'm not at the site where that SSID exists. What the other type of probe request we'll see is we'll see something like this. And this is a probe request that uses a wildcard parameter. It's not looking for any specific SSID. It's looking for any SSIDs. It just says, hey, anybody that can hear me, please send me a list of your SSIDs. Now, an AP with a hidden SSID will not respond back with that hidden SSID to a wildcard probe request. So you can't just send out a wildcard probe, say, hey, send me your SSIDs, and hope that the AP will send you back the name of the hidden one. It doesn't work like that. We have to do this directed one, and we have to have the name in it. So when we do that, so the MSU Bobcats one here, it's sending, and it has the specific SSID. For an example of a probe response, what we're going to do is we're going to pull up this one, and we're going to pretend that this one is MSU Bobcats, that we got a probe response back from an AP. And so our SSID down here, if it was MSU Bobcats, we would see that back. And what we would get is we'd have MSU Bobcats as our SSID, and more importantly, we would see the BSSID here of this value. And now we know that those two values are linked. We know that this BSSID has this SSID. Well, once we have those two values, now we can go back to our beacons, and we can look for a beacon that has that same BSSID. In this case, Gunslinger is being broadcast, so this isn't a perfect example, but if we pretend that, say, this BSSID was the one that we were looking for, now we know that this beacon that was not broadcasting an SSID, because the BSSIDs match between it and the probe response, we now know that this one is connected to MSU Bobcats. Now, looking at this here, you can look at it and say, hey, I can just do this in Wireshark. And yes, you can. You can just start listening for both beacons and probe responses, and you can kind of do a stare and compare. And you could just pull up and figure out, which ones are which. But in real life, especially with multiple hidden SSIDs and lots of SSIDs being broadcast and beaconed, you're going to have a ton more traffic. And so then you got to do a lot of filtering. It's not a quick process. So that's where our code is going to come into play here, is that it's going to automate this process. We're going to be able to run it. It's going to be able to identify which BSSIDs don't have a corresponding SSID that we can see from the beacons. And then we're going to look at probe responses, and we're going to attempt to match those up so that we can then find out what that SSID is. And it's going to be a lot quicker, as we'll see, than just doing a stare and compare between Wireshark there. So with all that being said, we've kind of looked at the high level view of this. We've talked about the process of how we're going to find what the hidden SSID is. So what we're going to do now is we're going to jump into the code portion of this, and we're going to see how we can translate that process into code using Scapy. So this is Scapy. This is actually my code editor. But this is the code that I've written to do that process. And so what we're going to do is we're just going to step through the code, and I'm going to explain, at a basic level, what we're doing and how that corresponds to that process that we just talked about. So Scapy, before we jump in, I've mentioned it a couple times here. It is a very powerful Python library that allows us to kind of analyze, dissect, create our own packets. Very powerful. Essentially, it allows us to take in a stream of packets and do whatever we want with it. And then also it allows us to make our own packets and send them out on the wire or send them out over the air. And so very powerful. We're not going to look at the creating packets in this video, but probably in the future we will. In this case, we're just going to look at packets as they come in. So in our Python code here, the only library we're going to be using is Scapy. And Scapy has a lot of different modules. We're only going to be using two, this .11 and sniff. Those are the two modules, but I am bringing in all so that they're available. And I like to do that when I'm kind of building up a program from scratch. So the first thing we're going to do is we've got a list here, and a list in Python is just a place where we can store information. And I've named it hidden, and what's going to go in this list is BSSIDs that we find from beacons that don't have an SSID attached. So that's going to be our first part of this program, and we want to get that list because then we're going to use that list, and that's going to be what we compare to probe responses. So these three that we have right here begin with def. These are functions, and this is where the bulk of our processing is going to be done. But I'm going to skip over them for just a second, and I'm going to jump down to these two lines that begin with sniff, because these are going to be what tells Scapy to start bringing in packets. So we're going to call this sniff function twice. The first time is going to be for our beacons, and the second time is going to be for probe responses. So sniff can take a bunch of different parameters. The ones that we have configured for our beacon one is the interface that we want to sniff on, EN0 in my case, which is my wireless adapter on my MacBook. The PRN, which this allows us to take each packet as it's processed and send it to a function to have something done. If we don't have that, it's just going to spit out the packet to the screen. And for the most part, you're not going to use Scapy to do that. That's something that you would typically do in Wireshark. It's a lot prettier to look at. So we typically are going to probably try and want to do something with the packets as they come in. The next parameter is just setting our wireless card to monitor mode so that we can passively listen on the air for all traffic. And then our final parameter is count. And all this is doing is it's saying process the first 100 packets or frames that come in and then stop. And for the purposes of this proof of concept, that is enough to get my hidden beacons that I'm looking for. So, or not the beacons obviously aren't hidden, but the beacons that have my hidden SSIDs. So we're just going to look at 100 of them and we're going to stop. But as we'll see in the next function, there are different ways to tell it to stop streaming in packets. So this is our beacon one. So the first thing we're going to do is it says we're going to pass each packet into the get hidden function. So we're going to go up and we're going to look at this get hidden function, and we're going to just kind of step through it and see what in fact it's doing. So in here, the first couple lines, what we're doing is we don't want this function to have to look at every packet. Well, every packet is coming in, but we don't want it to do the final commands on every packet. That's just a waste of processing. So what we're going to do is we're going to do a little bit of narrowing down, and if it doesn't meet these requirements, then we just drop out and we move to the next packet. So the first thing we're going to look at is, do we have the .11 layer in this packet? And that's, Scapy deals a lot with layers. They abstract the packet and the packet contents into layers, and in our case, we're looking for the .11 one because that tells us that it's a wireless frame. In my case, all of my traffic is going to be .11 because I'm sniffing on my wireless card right now. I shouldn't see anything that's not .11. So we're checking to see if it's a .11 frame. If it is, then we're going to check and we're going to see what type of frame it is. Now, we're looking at beacons, so if we think back to the overview a few minutes ago, remember that management frames always have the type 0. So that's the first thing we're checking. We're just checking, is the frame we're looking at a management frame? If it isn't, we're just going to drop right out and we're going to move to the next packet. If it is a management frame, then we need to see what type of management frame it is. And we're looking for a subtype of 8, which again is a beacon frame. So if both of those are true, and it's a wireless frame, it's a management frame, it's a beacon frame, we know that's something now we want to process. And so we're going to look at the beacon frame, and we're going to look for two things in particular. We're going to look first for this address to field, and we're going to see if it's already in our list, i.e. have we already processed it? And if it is in the list, we're just going to drop out. If it isn't in the list, we're going to look at some more information in that packet. Before we look at that though, I'm going to pull back up into PowerPoint. And we're just going to take a quick look here at the address fields. So each frame has 4 address fields. Typically, the 4th one is going to remain empty unless it's in a mesh network. Then we'll use that. But other than that, we're typically only going to see 1, 2, and 3. And so for management frames, our address 1 field is going to be our receiver address. In this case, with beacon frames, that is the all F's broadcast address, because we're sending it out to everyone. So it's not a specific client or anything that we're sending a beacon to. Address 2 is our transmitter address, and address 3 is our BSSID. And in this case, they are the same thing. So we're going to refer to address 2, or the code is our transmitter address, but it is the same as the BSSID. And we can see that if we pull back up into our Wireshark and we look at a beacon here, we can see that our transmitter address is the same as BSSID and our source address. They're all the same in this case. So we could refer to one of those other fields, but in this case, we're just going to refer to the transmitter address, which is address 2. So we've got address 2. In other words, our BSSID. Is it in the list? It's not in the list. So then we're going to look at this info field. And in Scapy, the info field for this packet is referring to our BSSID. And so we're looking for one where it's blank. Scapy is going to show this as this, which is an empty byte string. Just know that is referencing nothing, an empty SSID. So we're looking to see that value is in the info field. And if it is, then all we're going to do is we're going to take that BSSID, this address 2 again, and we're going to add it to our hidden list. And then we're going to move on to the next packet. That's really all we're doing is if it meets all these parameters, we're just adding that BSSID, and we're going to use that later on in the process. So that's it. That is all we're doing with the beacons. We're looking for ones that have a hidden SSID, and we're adding that BSSID to our list. Pretty easy function there. So once that has run through 100 frames, it's going to stop. And then we're going to move to our second sniff command. And our second one is going to look at probe responses. So same interface we're going to start streaming packets in on. This time though, we're going to pass packets to our get SSID function. We're still going to put it into monitor mode. But now we're using this parameter called stop filter. And stop filter is where we can specify a function that Sniff is going to check to determine whether it should keep processing packets or not. It also passes in the packet, just like these other functions, brings in the full packet. In my example, we're not checking anything in the packet itself. You can use this function as to say, if I encounter this value in a packet, or this parameter is true, then stop streaming. We're not looking for that. All we're looking for is we're looking to see if our list of BSSIDs is empty. Because if it's empty, that means, one, either we didn't find any hidden SSIDs when we did our scan of the beacons, or two, that we have identified all them after running our get SSID function, and it's now empty, and we can stop processing packets. So that's what that is doing. And that way, we're not running this to eternity, because we could set this to run for a certain amount of time. We could set it to run for a certain amount of packets. We could just let it run indefinitely. But in this case, we want to let it run until it's identified all hidden SSIDs. So when this function starts to run, we're going to start receiving packets. They're going to get sent to our get SSID function. And again, we're going to check and make sure that's a wireless frame. Yes, it is. We're going to check and make sure it's a management frame, because again, we're looking for probe requests, so management frame type, so we're still looking for type 0. Now though, we're looking for packet subtype 5, which is a probe response. We're no longer looking for beacons, we're looking for just probe responses. So if it's a wireless frame, a management frame, a probe response frame, then we're going to look to see if this probe response packet, if its address to, which is that transmitter address, which on a probe response is going to be the AP, because the AP is the one sending the probe response out. We are looking to see if that address, that BSSID, is in our list. If it isn't in the list, then we don't care. We're gonna drop out and we're gonna move to the next packet. If it is in the list, we're going to move to our next commands. And what we're going to do is we're just going to print the information to the screen then. And we're going to say that, for this BSSID address 2, it has SSID of whatever's contained in packet.info. In this case, in the probe response, this will not be empty. We're going to see our SSID in there. So that's just going to print that out to the screen so that you can see it live as we're processing packets. And then the final command is we're going to remove that BSSID, that value, from our list. And that's because once we've found it and we've identified it, we don't want to continue processing probe responses for that BSSID. We don't need to. We've already found the answer. So we're going to remove it from the list so that it no longer processes it. And so this will just keep going until it has removed all of the BSSIDs that it found from the list, and then hidden will be empty at that point and will drop out. So that is the code. So what we're going to do here is we're going to demonstrate it. And to help demonstrate it, we're going to put a couple of breakpoints in here that are going to stop the program or pause it once we reach certain points, so that we can just kind of view some of the data live. And so we're going to stop it here once it finishes. Stop it here. Once it finishes the beacons, before we start the probe responses, we're going to stop it so that we can see what's in our list. And then we're going to stop it each time it finds a BSSID that's in our list, so that we can kind of see what happens to that list as it goes. And so what we're going to do here is I have a client device, and I'm going to manually add my 3 test hidden SSIDs one at a time as we step through this. And as soon as I add them to my client device, they're going to start probing out on the network saying, hey, is there anybody that has this SSID? And so we should see right away a probe response come in for each of those as I add them. And I'm going to add them one at a time so we can kind of see the process multiple times. So the first thing that we're going to do is I'm actually going to clear them out of my client device right now. I still have them in there. And we're going to run the program. And so this first part of when we run it, it's going to run until it's counted 100 beacons. And that's all the time it took, just 2 seconds. And what we're going to do here is we're going to look at some of our information that's being stored in the program temporarily. And so we've got our hidden list. So these are the 3 BSSIDs that it found that did not have an SSID being broadcast in the beacon. So that corresponds with my 3 hidden test SSIDs that I've configured. So we've got our 3 here. Our next step is we need to look at probe responses and start matching these up so we can figure out what the SSIDs are. So what I'm going to do is I'm going to start processing again. And what it's doing now is it's just constantly running packets through this get SSID. And we don't have anything showing up yet. Nothing stopped because I don't have anything probing right now for a hidden SSID. So what I'm going to do is right now I'm configuring my first hidden one, which is called beacon test. And I'm saving it right now. And there we go. Within 2 seconds, we saw our first hidden SSID. So what it's done is it has printed out to my screen down here, if you can see, and it said this BSSID has this SSID, beacon test. And then we can still see we're still referencing hidden. We haven't run this command yet, so it has not yet removed our BSSID that starts with 26. It's not yet removed that from the list. We'll see it though in this next run through. So what I'm going to do is I'm going to start processing again. I'm going to go back to my client device. I'm going to add beacon test 2 and clicking save. And there we go. We've got beacon test 2. We can see it printed out again to the terminal. And now if we look at our hidden list over here, we only have 2 in there. Because again, we haven't run our command for the one we just found, but we got rid of the one that started with 26 because we no longer needed to find that. So we've now found 2, and we just have 1 more we need to look for. So we're going to start running through the process, looking at more packets, and I'm going to add the 3rd and last hidden SSID, beacon test 3, clicking save. And there we go. So we've now found all 3 of our hidden SSIDs. And it's printed them out to the screen so we can just see them real quick and say, okay, yeah, hey, this BSSID has this SSID now. And so I'm going to put one more breakpoint in here because the next thing this is going to do is it's going to remove the last BSSID out of our list. And when it runs the sniff command the next time, it's going to look at stop stream first. It's going to pop in there and it's going to check to see if our list is empty. And in this case, if we start it, yep, it jumped right in there. It is empty, so if not hidden means if it is empty, then we're going to return true back to the function, and that just tells the sniff function that, hey, I need to stop. I've reached my condition that tells me to stop sniffing. And so if I click our continue one more time, we're done. Program's done. We're not processing, not pulling anything else in, back to our terminal, and we've completed it. So that is the program. We can see that it was able to go out, gather those hidden beacons, store them, and then go look at probe responses and match them up to our BSSIDs that did not have an SSID, and we were able to, to publish that information out for you to see. What we're going to do now is, we kind of stepped through that, so it took a little bit longer than it would if you were just running it. So to show that example, we're just going to remove our breakpoints. I have those 3 SSIDs saved on my client device, and my client device is going to continually probe for those. I'm not connected to any of those 3, so it's just going to continually say, hey, are these available? So what we're going to do is we're just going to run the program, and we're going to see how long it takes for it to identify the 3 hidden SSIDs. Go ahead and we're just going to click run here. And so right now, by now it's obviously completed the beacon process. And so now what it's doing is it's just constantly listening for probe requests. And so while we're waiting, just one thing about this program is right now, it is only listening on the channel that I was connected on. And in my case, it's channel 100. I have an 80 megahertz wide channel. I'm the only one in the entire Uni 2 range in my building, so I'm not worried about stepping on anyone, but that's the channel it's sniffing on. We could add to this program, maybe the next logical step to this program is to make it hop through all the channels you want to scan on and bring those and run this process on each channel so that we can see all of the BSSIDs. And there we go, as I'm talking. So that took a while. But my client device is actively connected to an SSID, and it's not necessarily going to be probing all the time. Unlike beacons, which beacons, they're sending out a beacon for every SSID, every radio, and they're sending that 10 times per second, roughly. So if we have 2 SSIDs configured on a radio, or on an AP, and the AP has 2 radios, a 5 gig and a 2.4, we should see 4 beacons every 10th of a second, so 40 every second, because of the way that it sends out beacons. We don't see those nearly as often with probe requests, especially because my device is already connected to an SSID. So anyways, we can see here that took a little bit, maybe took a couple minutes or so. But we ended up getting the same information printed back out that we had before when we stepped through it one at a time. So that's still quicker than doing that manually in Wireshark. And if we were going to put this into full production, like some of the wireless hacking tools do, we would be using this in maybe a pretty heavily used area that has a lot of SSIDs, maybe quite a few hidden ones. And so it's a lot more traffic that we have to process. So that would be very tough to do in Wireshark. And with this, we can just let it run. And when it's found all the hidden ones, it'll show us and it drops out. So we've reached the end of this. This program, like I said, proof of concept, but we did prove that we can take that process that we talked about at the beginning and we can translate that to code using Scapy. And really, it's that easy. I mean, this actually maybe even has a few more lines of code than it would absolutely need to do this. But the way that we have it displayed is to make it really easy to read. But with that, I'd like to thank you for following along and have a good day.